Hello, it's time to do 7.7 complex numbers. So, what's so complex about them? Well, the deal is, used to be square root of a negative number, not cool. Like, you just can't do it because what does that mean, square root of a negative 1? It means like a number times itself is negative 1. But a plus times a plus, 1 times 1 is 1. Negative 1 times negative 1 is positive 1. So it just can't be. It just can't be that. So what we want to do here is, the way we want to define this is to go, the square root of negative 1, it's not a real number. It's imaginary. You can't do it, but we can call it something. We can call it I. I. So you can even put an I around it if you want. But the deal is, what's so cool about I? Well, so it's something that's not real. You can't really find it. But what's cool about it, if you do I squared, what does that mean? It's the square root of negative 1 squared. You can square that. And what happens is the square and the square root cancel each other out because they're like opposite actions. And what do you get? You get negative 1. So we're going to come back to that idea that I squared equals negative 1. It's a useful idea, and they use it a lot in different physical sciences. And particularly, the place that I've seen it in the most is electromagnetic field mechanics. So let's look at some problems, why don't we? So we got here is the square root of negative 25. Again, used to be can't do it, you just stop. But now we have a little bit of more tools. We keep expanding our tool belt. And the deal is, I can break that down to minus 1 times 25. So break it up into two parts, sort of like we were doing before with simplifying radicals. And here, oh, I know the square root of negative 1 becomes I on the outside. Oh, and the square root of 25 is 5. It's all times. So there you go. But the cool way to write it, or the way they usually write it, it's not so it's cool, but it's just the normal way they write it is they put the number first and the I second. It's like you treat the I like it's a variable, even though it stands for specifically the square root of negative 1. It's like pi. You say 5 pi. Here we say 5i. Right? How about the square root of negative 63? Again, it's minus 1. Break it into parts. Find that perfect square in there, 9 times 7. And what we can do there is, well, I know what the square root of negative 1 is. That's I. And I know what the square root of 9 is. It's 3. So basically, both of these guys come out. The 3 becomes 3. I'm going to put it in front of the I. And the square root, there's still 7 stuck underneath. So there you have it, this. Those are equal. The square root of negative 63 is indeed 3i square root of 7. So moving right along, how do we use all this stuff? Well, sometimes we got to work with our eyes. We have to work with the algebra of eyes. And basically, it's really similar to the other stuff. What I got here is a complex expression, 5 minus I. So that's like one guy here. And then I have another expression, 6 plus 4i. They're like binomials in a way, except we're using, instead of x's, we're using I. And then we can put those together, just like we did with x's and numbers. Well, put the numbers together, 11. And then what are the i's? I got minus I plus 4i is 3i, just like that. Same old, same old. It's really similar. So you play with it just like it's a variable in a way. Here's where it gets a little cooler in my mind. In my mind's eye. So what we got here is, now we're multiplying. So you can combine stuff, put your numbers and i's together, and play around with it just like we did with the radicals. The deal here is, when you multiply that, it's pretty cool because you just multiply it again like variables. You got 15i squared. we know, if you remember, we know that I squared is minus 1. So just put in the negative 1 for the I squared, and your final answer is negative 15. It's very cool. Usually when you multiply two things together, you never get a negative number. But because of that I deal, you do. So 5i times 3i is negative 15. Cool, eh? All right, let's get even cooler. Let's look at this child. 3 plus I squared. Now, if you remember, just like with x plus y squared, the only way to do this is to FOIL it. You can't just square both because there's a plus in there. Remember how to FOIL this? 3 times 3, 3 times I times 3, I times I. So you get 9 plus 3i plus 3i plus I squared. What does that make? Well, you got your 9, you got 6 i's, and then I squared is minus 1. So then for a grand total of 8 plus 6i. Where's that minus? I gotta check. Plus 6i. There's your answer. Kind of cool, eh? So here, and then we get into this idea of the conjugate. Remember the conjugate stuff? So what if it's 3 plus I times 3 minus I? Oh, that's cool, because you go, FOIL. So what you get is 9. 3 times 3, the first, then the outers, minus 3i, plus 3i, we love it, minus I squared. So what happens there? We got, well, these guys cancels. So we's got 9 minus I squared. Oh, and I know that's the same thing as 9 minus negative 1, which becomes 9 plus 1. We know that. 2 minuses make a plusy. So for the grand total of 10. Cool. That is cool. So something that looks like this. 3 plus I times 3 minus y, and you multiply this conjugate thing, the i's cancels, and it turns into a negative 1, and you wind up getting 10. Nice. Ooh, cool. And again, how can you use this? How does it help you in life? Well, that's a bigger question. I don't have the answer to that. But I do know, you play around with stuff. You don't let it phase you. It's algebra, reasoning. You play with it just like with its numbers, but you treat it with variables, or whether it's roots or i's. And so we have this situation, 5 over I. Remember how we rationalize denominators? Same deal. Let's realize, make the denominators real. And the way to do that is, well, that's I. Why don't we multiply that by I on the bottom and the top? And then what you get is I squared 5i. And then, oh, I know what that is. That's equal to 5i over negative 1. And then you can just bring the negative 1 upstairs. And there's your answers. So that actually does make that look a lot better, don't you think? It's not a fraction anymore. So you can rationalize, or it's not really called rationalize, it's realizing. They don't really call it that either. But make the denominator real, not imaginary. And then it's easier to deal with, especially if you want to add stuff or subtract or just work with it. It's just simplifying. Simplifying. We want to simplify life. Yes? And last but not least, the other thing, when it looks like this, it's like, oh man, I can't deal with that fraction. So what should we do? I'll tell you what we can do. Let's multiply by the conjugate, just like we did with roots, except this time we're going to multiply this sucker by this sucker. Whatever, do the bottom to the top. And since it's a whole thing we're multiplying, I got to put that in parentheses. So what happens? Let's work the bottom first. The bottom becomes, when you do your thing, you get 16 plus 4i. That's the first times the first and outer. Now the inner, minus 4i. That's what we want, minus I squared. Okay. And on the tops, we got 2 times 4 is 8, plus 2i, plus 4i. 4i's plus I squared. And that's all one big fraction. All right, let's go to the next page. So then just to tidy up this problem, we multiplied it all out, and the bottom, it's nice what the bottom becomes, because you get 16 minus I squared. On the top you get, what is that, 8 plus 6i plus I squared. We know what that equals. That's 8 plus 6i minus 1. And on the bottom is 16 minus a negative 1. Oh, minus a negative 1 is plus 1. So what we get for the grand total, after all that, is 7 plus 6i over 17, which is kind of amazing in terms of what we started with, but it looks like that. But that's definitely simpler. We made it look a lot nicer. At least there's only one I and it's upstairs. If you remember what we started with. Whoa. Whoops, that's not what I wanted. It's this one. So we had, that wasn't it. This was the original problem. This guy right here. Well, that was our original problem. We zapped it by this, multiplied by the conjugate, worked that thing, multiplied it all, foiled it out, and we got to this answer, which I think is lovely. And that's about it for eyes. You don't have to do much more with that. Again, if you ever take any electromagnetic field stuff, you'll be using your eyes. You won't use it too much others. If you take any calculus or pre-calculus classes, it'll come up again. But that's about it. So this is everything that you need for the test. So that's 7-1 through 7-7. So good luck and carry on.